This video is for the makeup of VC6, so please download the VC6 Java file and make sure that you can run it. I'm going to go ahead and click on Run. What you'll see is a bunch of nulls, and it's actually prompting and waiting on a scanner. So we're going to be going over recursion today. This is a pretty mind-bending topic, and it's really too bad that you guys aren't doing it live, because really there's a lot of learning that happens in this topic, and you can only learn by doing it yourself. So please don't just copy the code here and submit. I really want you to try it on your own. Before I give you the code, try it on your own and try it out, and if it doesn't work, think about why it's not working, okay? So the first one is going to be write nums, and it's actually one of the practice problems, but it's a good one. So it's a very simple recursive problem. We're just going to print out the numbers from 1 to n separated by commas. We know how to do this iteratively, right? We know that we have to do a 1, and then every loop after that, we have to do a comma 2, a comma 3, a comma 4, a comma 5, etc., right? So that's actually the very first, most important step in recursion, is to figure out what do you have to do in any one iteration or one call of the function, and what should the recursive call do. So what we already know from experience is that the recursive call, the next call, should put a comma and a number. And we know that there's a base case where it has to print just 1 on its own. So using that, we're going to start writing some cases. So I always want you to put a comment for what the cases are that you think you're going to need to deal with. So there's going to be a base case, and there's going to be a recursive case. Sometimes there's more. In this case, it's just going to be a base case or a recursive case. And again, what is that first base case? The base case is going to be when n equals 1, all we have to do is just print 1. What's the recursive case? For anything else, we're going to print comma and then a number. Okay, that's what our goal is. Okay, and it's also important to figure out which direction are you going to be recursively calling. Usually you'll be recursively calling down, so n to n minus 1, but sometimes you will be recursively calling up, and we'll see an example of that. So let's start writing this code. So if n equals 1, then what? Then we're going to sys out of just 1. So, and I didn't actually make a call here, but I'm going to add a call. It's always a good idea to test your code. Okay, that sounds pretty obvious, but it is. So I'm going to run this code, and let's see what the output was. Okay, because this is not always going to work. The base case is not always going to work. It's important to figure that out. So we know that our base case is right. So next call is going to be like, for example, with 2. So if it's called with 2, it's not going to fall into this case. We're going to have a recursive case. So else, let's get these lines over. So if it's going to be 2, we're going to need to call 1 first, and then we're going to print out comma 2, right? So let's do that. We're going to get the 1 by calling write nums of n minus 1. Not 1 itself, but whatever n minus 1 is. So in the case of 3, we would call write nums of 2. Okay, and the case of 5, we would call write nums of 4. Then we know that we need to print out a comma and a number. All right. I think that's correct. Let's try running that. Okay, oh, we got a little problem with the printlns. Let's not println. And that's actually why I had to do printlns in between each of these test cases. Otherwise, it just runs together. So that is how it works. So notice at each point here, so in the case of 10, what we have to do is get write nums of 9, which is going to print out this Is it going to print out the comma? No, it shouldn't, because we know from experience that you have to print the 1 by itself, and then every number after that you print the comma number, right? So what we know is we need to print the comma number here, and before that we need to print right nums of 9. Let's take the case of right nums of 9. Okay, we know that we need to print comma 9 here, and then right nums of 8. Okay, so that's a pretty straightforward example. Now I've got a slightly different case. You notice that in this case we're printing stuff. You should probably be asking yourself, do we always have to print stuff? And the answer is no. You can also pass strings around. So we're going to do this exact same example, except this time we're going to return the string. So very similar code. In fact, let's go ahead and copy it, and then we'll modify it. So again, at this point, you should stop the video and try to do it on your own. Only if you cannot figure it out should you be taking a look at the code that I'm going to make here. All right, so in the case of, so hopefully you tried it out on your own, and now we're going to see what is necessary. So instead of printing 1, what we're going to do is return that string. And so it's still the same base case. We're just returning. And then if it's not, now we need to slightly modify this. We can't have 2 lines with this print one. We're actually going to return, because we want to do something with this right nums. And then we're going to concatenate comma n. And I've got a paren here. And let's see, what is it saying? Oh, I think I just need to, oh, I got to change name, not right nums, but string nums. Okay, so what this is going to do, in the case of just 1, it's going to return 1. In the case of 2, it's going to return string nums of 2 minus 1, 1, which is just going to be 1. And then we have to print the comma 2. In the case of 3, it's going to come down here, it's going to call string nums of 2, which is going to print 1 comma 2, and then we have to print comma 3. So again, it's always about figuring out what does the recursive call need to do over here, and what do I need to do? Okay, those 2 separate things. So that's the same function, just returning strings. Now, you should notice that so far we've been counting down, right? We go from n, count n minus 1, and now let me modify this. So we're going to do the same thing, but we're going to recurse up. Okay, so instead of recursing down, we're actually going to recurse up. So if we're going to recurse up, string up nums of n, let's say n is 10, okay, we're going to start at some number, and then we're going to go up. So what happens if we start at n? We start at 10, and then we try to go up. Well, we've gone too far, right? N was supposed to be the last number. That's why typically you would go down. But we can still make this work. But if we're going to go up, we have to start at something lower than 10, right? Where should we start? 0 actually doesn't make any sense, or at least we're planning on starting at 1, right? That's what the problem says. So 1 is really the first place to start. So we're going to want to call string up nums with 1, and then we're going to go up. And we can see how that would work. It would go 2, 3, 4. But how are we going to know when to stop? I want you to stop the video for a second and think about how are we going to know when to stop? That's a very important thing in recursion. It's a bit of a trick question, though, because the answer is you can't. You need to use a helper function. This is why helper functions were created, is because you can't just recurse. You would do it iteratively by having like a local variable. Okay, but with recursion, you don't have local variables. You have parameters. So what we've done is we've added a string up nums helper, and now we have a current parameter. So that's not going to be 10 or n. Okay, that number goes here. This current starts at some value. We've already talked about what's that first value. It's going to be 1, and then it comes 2, and then 3, and 4, 5. Okay, so we're going to have to replace this call with string up nums helper. And so think for a second, stop the video. What are the goal and what is the current? So the goal here is actually going to be n. Current, what's the first one? That's actually going to be 1. That's where we're going to start. Now, we have to figure out what actually goes in the body here. So we're counting up numbers, and we've got the helper. So what's going to happen here? So again, I said we should always have some base cases here. So we should have a base case where we'll just leave it base case for now. And we're also going to have recursive case. So let's think, what is the base case? So we know one base case where the number is 1, right? Current. If current is equal to 1, then we're just going to return 1, right? Okay, recursive case. So in the recursive case, what we need to do is we need to call the string, I'm going to abbreviate, string up num helper of the goal never changes. The goal is always the same goal, but the current is going to increase by 1. So we know we've got to do something with that. But what else do we have to do? Let's go back to our cases. So we know that calling it for 1, it should just return 1. What should it do for 2? For 2, it's got to print out the 1, but it's also got to print out comma 2. We've got to do that at some point. So we have to do, it's going to have a comma number, current, and then we have to concatenate on whatever the next one is. So let's take a look at doing this here. If current equals 1, and return 1. Now this is not completely right, but we're just going to start with it, right? Else, let's give some curly braces here. So else, we're going to try calling recursively comma within current, and we're going to call string up nums helper goal and current plus 1. Okay, so let's think about this. So if we call it with 1, it's just going to return 1. We call it with 2. The difference using this helper is that it's actually going to call it with 1, 2, comma 1. Okay, so it's going to call, the goal is 2, but it's going to start with the current being 1. So it's going to come in here, and it's going to see the current is equal to 1, and it's going to return 1, and that's it. So if I run this, let's see, what's the error? Got to return. That's an error, and then I think that's just a reminder there. Okay, so let's run it again now. Okay, so let's see what the calls were. So string up nums are calling with 1 and 20. And in both cases, all it does is just prints out 1. And that's a very common problem. So with this helper, you can't just print out 1 and be done, because you definitely need to print out the 1 by itself, but then you need to recursively call it, because otherwise it just stops. So we actually have to call this plus string up nums helper of goal and current plus 1. Now if we do that, it's going to call it with 2. It's going to print the 1, and then it's going to call up the helper of 2. So what happens when it does 2? It's going to come down into this case for 2, so we printed 1. Now it's going to print comma 2, and then it's going to call goal helper of 3. Okay, let's just try running it and see what happens. Whoa, we had a stack overflow. It blew up. And that's because it called it with 3, and then it called it with 4, and then 5. We forgot there's a new base case here. So there's another base case. Else if current greater than goal. This is going to be our failure case. So in the failure case, if the current is greater than goal, what do we do? So remember we got to 3. What do we want to do when it gets to 3 and the goal was 2? Well, we actually don't want to do anything. So all you have to do is just get out of there. And to get out of here, you're just going to return null. So now let's try running it. Okay, this is looking a lot better. So in this case, we had, when you're counting up, you have to worry about going too far. When you're counting down, your base case is going to, check for 0 or 1 or something like that. So in that case, it's already caught for you. But in this case, we actually had to catch it separately. And then we have a recursive case. So that is how you use a helper. Okay. Now, the next problem is utilizes that helper, but it also utilizes recursive backtracking. And I'm not going to spend the time to go over this because it's already been gone over in the second of the 2 lecture videos. Go and watch the second of the 2 lecture videos so you understand what the traveling northeast problem is about. Okay, that just understanding what the problem is about is a big part of understanding how to solve the problem. So I'm going to assume that now you've already watched that other video to understand how it works. And so what we've done is I've already created the code here to input an X and a Y. And then it's going to call, this is travel northeast with that X and a Y. Now the next question is how, so in the grid here, let me bring up, I just need a grid to show you what I'm talking about. So similar to the string up nums problem, we are going to be trying to put together a solution not by going down, but by going up. That's actually an interesting question if you could do it going down from 2, 3 to 0, 0. But we're not. We're going to follow the same example as the book Traveling Northeast. So we're going to go up from 0, 0. So we have to know when we've gone too far. So you can travel this way, you can travel like this, and this way you found it. What if you went over here and then you went over here? Well, once you're here, you want to stop. Or what if you went over here and then you went all the way up here? You'd want to stop. Okay. So in order to stop, you have to know where you are in the maze and what the goal is. And you can't do that with just these 2 parameters. So that's why we need a helper function. So let me go back to here, and I want you to figure out, you should stop the video and figure out what do you need to call this helper function with. And by the way, this is the same name, but it works fine because they have different signatures because we have all these extra parameters here. So we have a target X and a target Y. Those are the same. So we're still going to call travel of target X and target Y. Now, what is the current X and the current Y? So initially, the current X and the current Y are going to be 0, 0. And then they will change as you go through the maze going up. So we're going to start with 0, 0. And then what is the initial path? What is the path when it's right here? Well, it's nothing. You haven't gone anywhere. And that's what you want to put in here. You want to put nothing. So that is the initial condition. Now, we need to work on the actual code here. So here, again, you want to think about what are the base cases and what is the recursive case. So similar to how I was analyzing it in string up, you need to look at what the answer is going to look like in each case. So for example, in this case, the path I'm going up here, this path is going to result in a path of being north. Sorry if you can't read that too easily. That's north. When we get here, that's northeast. Trying to do this with my mouse. Let me get my pen back out. When we go up here, this is going to be northeast, north. Over here, it's going to be north, east, north, and then east. And then here, finally, it's going to be north, east, north, east, north. And that's where it ends. Okay? So we know that at each step, what our job is to add a north or an east on to the path. So that's our recursive case. What is our base case? How do we know when we're going to stop? Remember the string up problem, we stopped when we reached the goal, right? So we know we want to, when we reach that goal, we definitely want to stop. Okay, so let's write that down. Stop. Okay. There's another base case though. Remember also we had a base case in the string up that if we went too far, so if we're counting up to 20 and we get to 21, we need to stop, right? So we need in this case, it's this example right here. We've gone too far. So now what's this path here? This path was, let's say it was this one here. So this is an east, and then I won't draw that, but it goes east, north, 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 north. So this path is east, north, 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 north. Now, what do we want to do with this path at this point when we realize it's too far? Do we want to print it? No. We actually want to throw it away. So when we get too far, we need to actually throw the path away. So we want to print the path in this case. But another base case is, or a failure case, when exceed the goal, discard the path. That's an important case. So let's start coding this up now. So base case, if, now I definitely should stop the video and try coding this up on your own if you haven't already. So what we're going to do now is we're going to, when we've reached the goal, so if the target x, let's do the current x equals target x, and cur y equals target y, then what do we have to do? We want to print the path. And then I'm going to return. We could probably structure this without returns, but I'm just going to go ahead and use that for now. Else, there's a failure case. So if, and how do we determine it's failure? We've gone too far. So cur x equals target x, or cur y equals, you know what, for a moment, I'm not going to do the y. I'm just going to do the x for a moment, and then we'll come back to that. So, sorry, greater than. So if it's greater than, what do we want to do? This is the failure case, and when we exceed the goal, we want to discard the path. So we're just going to return here. We're not going to do anything with that path. Finally, for the recursive case, we got to add north or east of the path. Let's just do the east case. So what we're going to do is we know we need to call travel with the target never changes, same as in my last example. No, sorry, not. target Y. Now the currents do. So I'm going to start, just list them first. Okay, but we got to make some changes. So if we want to go east, that means the X increases. So we're going to increase the X, and the path is going to add on an east. Okay. So let's try running this. Okay, so it's asking us now. So we are set to go east. So I'm going to say the target is 3 and 0. And it worked. East, east, east. So let's try another one. 3 and 1. Nothing happened. So I'm not sure why my machine didn't crash. It should have crashed, but it's just not returning. The problem is that it's never getting, because the Y, we never get there. It's going on forever. So we have to fix this by changing the. We never got back to finish this. So if the current is too great for in the X direction, or the current Y is greater than the target Y. So that'll stop us from recursing forever. Let's try, but we're not done yet, because now we've got to actually call, and this is a part that confuses a lot of students. I'll explain it in a second. Let me call, just copy and paste this in here. So now it's not there, it's +1. And then in this case, the path is north. Okay, so let's try running that. Now let's go 3 and 1. You see the different paths that it has to do that. So why is it that we're having these two calls here? A lot of times students think, shouldn't these be in like separate cases or something? So let's go back to the drawing. So what we're doing here is we're trying to add, sorry, let me get the, so we're starting here, and then we're going to go first north. And then at this point here, our job, a lot of students think that at this point we need to check. We need to check. Have we gone too far? And that's a very common problem. You don't need to check anything, because you just leave that to your base cases. Check to see whether it's too far. Check to see whether, leave your base case and check whether you've reached it. All you need to do is at any given point, you need to go north and you need to go east, and let recursion do the rest of the work for you. Somebody else commented, is this similar to, there's a binary, count binary problem. And it is similar to a count binary problem. Okay, in a count binary problem, you have a choice of going 0 or 1, and then you have to recursively call to do the rest of the work for you. And this is maybe the toughest part for students to grasp, is that, what do you mean you're just going to call recursion and then you don't have to do anything? Like, don't I need to then go over here and see whether I've gone too far? Don't I need to check to see whether I'm done? And the answer is no. You let recursion do that for you. Okay, that is the big learning here. You have to trust the system that recursion will do the work for you if you set up your base cases. All you got to do is actually make the recursive calls. It's confusing to some students. Why are we doing 2 of these things here? Well, because if you don't do 2 of them, you only ever explore the north path. You have to explore the east path too. That's why you have to do both of these. We saw what happened if you don't explore one of these paths. It'll just go on forever, keep on going farther and farther and farther. And so you have to explore the north path and the east path. And when you're calling travel, it's going to do the rest of the exploration for you. So that's the end of what I wanted to show you. There's a lot of learning that goes on here by trying these out and making your own mistakes. So I really hope that you have followed along and done the work on your own, because otherwise it's not going to be any use to you. So anyways, I hope that helps with your understanding of recursion. Now there's also a section about the quiz, and let me briefly pull up that page. So the quiz is next Monday. It is not going to cover recursion, what we talked about today. It's going to instead cover the last few chapters, inheritance and polymorphism, array lists, and Java collections with lists, sets, and maps. So those are the topics that it's going to cover. So briefly, I want you to recall the ecosystem. Recall, what is the polymorphic part of code? A lot of people still, even today, think, oh, the Orca, that's polymorphic. And it is not. The Orca code does very specific things it's pre-programmed to do. It doesn't do different things depending on what classes it's interacting with. What is polymorphic is the ecosystem. When you called eat, that is polymorphic, okay? And think about how would you add another class to the polymorphic code. The mistake a lot of people did is that in the ecosystem they tried to specifically hard-code it. So they hard-coded that there was a shark class and an orca class and a salmon class, rather than just sticking all these into an array and having a loop calling through eat. They tried to call each of those 3 eats. Okay, so that is the wrong way to do it. The right way to do it is to just take whatever is in the array and call polymorphically the eat method on them. The array lists. So particular catches with array lists, make sure you understand the advantages and disadvantages of for each, especially with regards to removing and iteration. Okay. Also, in for each loops, if you do remove with an index, you have to adjust your indices so that you're not accidentally stepping over the same item twice or skipping over an item. Java collections. So this chart I go over in detail in my lecture video, and it's not in the book, and I give the answers in there if you follow through. But this is very important. It's really the most important thing you'll learn in this class, because a lot of this stuff you can go and Google. How do I implement a hash map? How do I implement a linked list? How do I implement an array list? But what you can't Google easily is, for my particular problem, let's say I am storing the IDs and social security numbers and names of people. What structure should I use? That's what this map here is trying to figure out. So you have to fill in the boxes for how do you decide this. So for example, there's these 2 boxes. These are the same boxes that if you say yes, you want a tree set or a tree map. And if you say no, then it's a hash set or a hash map. What's that question? It's whether you want sorted data. Okay, so what goes in here is the box saying sorted. If it's yes, then you want a tree. If it's no, it's a hash. How about this box up here? What is this choice here? That if you want single, you go down this path to all these other things. If you want double, you go down this path to the maps. It's how many data items you have to deal with. Do you have 2 pieces of data or just 1, right? So if you got a pair of data, you want to use a map. A single piece of data, you're going to have to store it in something else. So there's answers for each of these boxes. It's very important for the long-term use of this class that you understand how to draw this map, and it's also important for the quiz. Make sure you understand what are the advantages of these various items. These are all good questions that will help you make you think about that. But yeah, make sure you understand all of these things. So I've got a few exercises here you can try. I would definitely say the most important thing to do well in this quiz is the homeworks. If you understand how to do the homeworks, then you should be great. But I've got a few extra practice problems you can do here as well. It's mostly coding. You're going to have to code up a map. You're going to have to code up a set. You're going to have to code up a list, an array list. So yeah, there's going to be coding. There's also going to be some short answer questions. Same rules as before. Monday quiz. So that's what you need to know about preparing for the quiz. So please submit the Eclipse. Submit this Eclipse file that you implemented, and yeah, that's all you have to submit. You don't have to submit anything for the quiz. You're obviously going to take a quiz. So hopefully that was helpful for you. Okay, good night.